All right, then.
Welcome to Amy Benzi's QL Misfits XL2 presentation.
I'm Amy Benzi.
I'm John Tenney.
Lydia Souls.
McCree Martin.
Janet Bailey.
Just proud to be here.
Next slide, please. Tenny, do the half-lives of medication affect our lives?
They certainly do. They affect mine. I have to take blood pressure medicine morning and night, and have had to for years and years. And on this graph and the slide they're seeing here, you'll see where the half-lives are on the left-hand side. I take 100 milligrams morning and night, and it's a time release type deal. And about every 12 hours, you can see that I only have about between 6.25 milligrams and 12.5 milligrams in my system as it wears off. And then I take another one, and it keeps my blood pressure, where'd it go? Keeps my blood pressure regulated as, as the day and the night goes, where I don't have too much blood pressure. I've lost some weight, and I hope to not even have to take any of these pills before long. Ms. Benji asked me about the half-life of marijuana here a while back. I talk on it. If you look at the half-lives of marijuana, it stays in your system for quite some time because, say, 25 milligrams or nanograms of marijuana, 30 hours later, you still have 12.5 nanograms in your system. You'll have it in your system for over 30 days, and it breaks down so slowly in your system that it stays there. And the way that would affect your life is if you're seeking employment. Most places do not want someone that uses drugs. They usually have them provide a urine test. If your urine test shows positive for marijuana or cannabis, you don't get the job. On the graphs on the right, was I done?
My apologies.
On the graphs on the right, there was one of our vocabulary words that we needed to talk about was asymptote. And an asymptote is a curved line that just goes on and on and on and on for infinity. The E on this is an exponent. And those lines, as much as they look like they connect, they don't ever connect at a finite point. They just keep going and going and going forever. And it works on all the different charts that we made up on this.
Very good. Thank you, Tinny. All right. So, Tinny, go ahead and ask Bailey.
Oh, Ms. Bailey, explain the half-life of Nexium and even what Nexium is.
Nexium is a heartburn medication that is either prescribed by the doctor or bought over the counter. And the bottle says that it's good for 24 hours. But after looking at the half-life in my report, it's really only good for a little over 18 hours. The half-life starts in 1 hour, 1.425 hours, and it continues to cut itself in half until it gets down to 0.1%. And you have to take it every day.
Wow. Thank you for sharing that, Bailey. Souls, can you go ahead and switch the slide?
Yeah, can you switch the slide?
Lydia, what is an asymptote?
What is an asymptote?
An asymptote is a number that never, ever, ever touches zero on either the vertical or the horizontal axis. This, in this case, it is a horizontal asymptote, and in that it will never touch the x-axis. The interesting thing about this was when I was looking it over, specifically the half-life of aspirin. If you take aspirin to the level that you should take it for arthritis specifically, and you also take an aspirin regimen, 9.5 hours later, you still have more than your arthritis or than your aspirin regimen for your heart or whatever blood thinner use in your system. So being aware of half-lives is very important.
Very good. Thank you, Lydia.
Janet, could you explain why knowing the half-life of medication is really important?
The half-life of medication is important because
My apologies. It's important in real life.
the half-life of medication is important in real life because people feel like they need to take more of something. I still don't feel good. I need more. I'm still in pain. I need more. So being able to calculate the half-life is a good way for people to understand, do they really need more, or do they need to wait long enough for it to safely be administered throughout their body? So this is extremely important for the elder or for children or for people who are sensitive to medication, such as diabetics or people with high blood pressure or things of that nature, where it's really critical to know what the half-life is. If you take too much insulin, you could die. If you take too much blood pressure, I mean, there's just a lot of risks to not knowing and just playing doctor and saying, I need more.
Very good. Thank you, Bailey.
Tinny, can we assume that the foods that we eat have no effect on our health?
I would think not. The old saying goes, you know, what we are, what we eat, has never been sure about the foods we have nowadays. These charts and this data here talks about these genetically modified foods that use Roundup herbicide. It's called glyphosate, I guess is what it's called. And I use Roundup around my house.
I'm sorry, Lydia, can you put yours on mute, please, while Tinny's talking? Are you guys in the same room?
What's up?
Lydia, you put yours on mute, your mic.
Or Lydia, put yours on mute while Tinny's talking.
His mic was picking up earlier. That's why I turned off my audio so it would be arguing.
I'm okay.
All right, go ahead.
Get his mic muted, and then I can turn the audio back on and hear
Can y'all
what's
hear
going
me
on.
now?
All right, go ahead, Tinny. I'm very sorry.
Is that too much?
Okay, hold on.
Perfect.
Let me turn the audio back on and we'll see. Because that's what
Perfect.
I had
Just
to do.
keep
I had
going. Just keep going. I'm sorry.
Okay.
Yeah.
I would think not, but you know, you are what you eat. This graph shows how that the genetically modified foods has affected children with autism. Back in the 90s, there was hardly any tons of glyphosate applied to foods, corn and soy. As the years went on, there was more and more tonnage of this chemical used on the food. The amount of children that had autism in 92 was only 10,000. By the time 2009 rolls around, we got 375 children, or 375,000 children that have autism. And so these foods, we have to worry about the correlation of that. You know, is it these things, the using of these herbicides and everything on our foods is causing some of these, or can we look at causation? Causation is the act or process of causing. And I think the genetically modified foods have certainly caused health problems over the years.
Thank you, Tinny. Excellent.
I can't read it. Is there a way I can move that slide where I can read what's over there?
I haven't figured it out yet.
McGree,
The question is, what is a correlation?
Okay.
And the correlation of the two things here, although I found it interesting, the genetically modified foods, I took those same stats and transferred them to Roundup versus peritonitis, which was the intestinal illness, and arthritis. And I found that, as you can see, that line, it's still there. but it goes all the way from 1990. It is underneath the top of the glyphosate, both the arthritis and the thing is, and the fact that even it dips when it dips is as creepy as it gets. But unfortunately, unless we had blood tests from every person in this thing, we couldn't prove that is the cause. So we can't say it's a cause, but it is a correlation. It is a very obvious, clear changes occurring exactly when those changes occurred. Interesting thing, one last thing, is that these correlations correspond to when the Roundup was sprayed, not when the food was consumed. Even the peritonitis, that is a digestive illness, it doesn't correlate to when it would have been consumed, possibly a year and a half to 2 years later.
Very interesting.
Anything that was sprayed with it or received it. Is impaired driving a problem in Garland County, Tinny?
Impaired driving in Garland County is certainly a problem. This Venn diagram is very spot on for the way things are. I'm a drug recognition expert. I've been through a lot of training to understand that. And we talked about polydrugging, drugging quite a lot in our DRE class, because most everybody that uses one drug, say alcohol, also has other types of drugs in their system, whether it be another depressant like Xanax or clonazepam, or they have weed in their system or things like this. And the way this Venn diagram goes, it shows the overlapping of it and the percentages that people have with these other drugs in their system. In Garland County, we've helped the impaired driving problem because we've really had some strong enforcement over them and over the years, and it's a lot better than it was. And it seems to me nowadays that the impaired driving is more from drugs, prescription drugs, people that overuse their painkillers or overuse their muscle relaxers or things like that. And as we were talking about earlier, people that just use what was it you called for your allergies?
Benadryl.
Benadryl. Just people that use Benadryl, that use Benadryl, and they hop in a car and they got to drive to the grocery store. They drive and pick up their kiddo or something like that, and they fall asleep or they drive crazy all over the road. So yes, impaired driving is a problem in Garland County. Let's see here, back to Lydia. Let me move this out of the way. What is the maximum number of sections on a Venn diagram, Lydia?
Well, if it's not a 3D diagram, then you can really only get them all across in 4. Otherwise, you're going to have a thing. But if you did it in 3D, you could do a little bit more. This one was really interesting because it specifically discussed how many people had multiple things they might not consider stupid, and how really the interesting thing is that the good thing, 59.9% said you guys are idiots. We aren't going to take it.
Very good. Thanks, Lydia. You always make it so fun.
You got to ask.
Oh, yeah. Sorry. What does the Venn diagram represent, and what does each section reflect?
The Venn diagram represents
just ignore it and go back to what you're doing.
the Venn diagram represents the test subjects that tested positive for a substance when they were involved in an accident, and every section represents something else. So if you look at the overlapping sections on alcohol, for instance, the bottom portion that kind of looks like a teardrop represents that 26 of the test subjects also tested positive for medication and alcohol. Or you could say that 18 people tested positive for alcohol and cannabis. So the Venn diagram just represents an entire study of people kind of all put into one graph as they overlap each other and can fall into different categories.
Very nice. Thank you, Bailey.
McCree, how do you maneuver around the Venn diagram?
All right, so you guys were talking about the Venn diagrams and all of the specifics around it. And it's almost kind of confusing about how it looks and all the different numbers. It's almost intimidating looking at it. And I wanted to talk about how each of these circles and the numbers in them. So when you see them overlap one another and together, that's when they come together. So for the drugs like alcohol and cannabis, you can see that they're overlapping right there next to the 106 and the 41. In the middle, you got 18. That's how much, or that's when they have alcohol and cannabis in their system at the same time. So this is an impaired driving Venn diagram. And yeah, you can see how I just how they all flow together and connect to each other.
Very good. Thank you, McCree.
What is an outlier?
When I did this map and tried to do this chart, I found why they didn't do a chart for this particular set of evidence. The green is women who had little to nothing in their system. In some cases, it was so little that it could have been what they got off of a dollar bill. The yellow was men. The crazy red are the female junkies. And as you can see, their results were so completely different that it edited everything in that chart. There's no way you could honestly average it. It would make the ones who had a serious problem that they dealt with disappear. Well, it wouldn't disappear, but it would make all the other women look stupid. And in this final thing, the only way to make this an honest chart was put a clean men, which came out to normal, and women who were exceptionally stupid.
Very interesting, as always.
That was an outlier.
Very good. Thank you, Souls.
Explain the difference between a box and whisker graph.
Oh, that's my fault.
Explain the difference in the box and whisker graphs and what the data makes them so different and why. Janet.
The box and whisker graphs plots are these boxes on the screen that represent a certain amount of data. And as you can see, the data for the 25 to 69-year-olds is a lot more slender than that of the 70-year-olds. And the reason that it is because of the variation in the outcome of the tests. So if you look at the graph for the 70-year-olds, their information is not as consistent as with the 25 to 69-year-olds, which makes such a difference in the graphs. If you were to swap information out and make the 70-year-old graph a little bit more even, then the box and whisker plot would actually become more narrow.
Very good. Good explanation. Thank you. Good visual.
What are these parables and why do they look so weird?
These three parabolas look so weird because I put them on the scale so that we could correlate the information. As long as you had them, you could make a normal parabola out of them, a simple bell curve, and they'd all look the same. But if you didn't change the axes, you could not tell where and how they related to each other. In the first case, the senior citizens weren't even on the charts. They'd be over here in the two younger groups. In the, excuse me, I just did it to myself. In the middle one, the 25 to 69 group, you can see the number was a little taller. That has to do with how spread out the information is. Because the information is more spread out, it's a little bit shorter. But the 16 to 24 group was extremely spread out. So it is much wider and shorter than the other two.
And I can see how the bell shapes do look an awful lot like.
How bad is the problem of distracted
just-
driving?
If you didn't have the ending asymptote at the end. But they do have some very similar characteristics as parabolas. Very good. Thank you. Go ahead, Souls.
No,
Go ahead, Souls.
Okay. How bad is the problem of distracted driving?
The problem of distracted driving is terrible in Hot Springs. Nowadays, everybody's got a phone, and they're all interested in whatever kind of information it may contain, whether it be the most major thing in the world to them or the most trivial pursuit thing that they can find. This graph shows a standard deviation of the 16 to 24-year-old group, starting out where they, with the amount of usage that they use more and more nowadays than they used to. You can see the trend line on the graph to the left, the chart to the left, how that it started out, pretty low, and then now as the years that went by, it's gotten more and more and more of these folks are using. Everybody has a cell phone. For me, what I do is I work as a police officer, and I see the results of distracted driving daily with accidents, major and minor. I see people leaving all over the roadway. They look worse than if they're a drunk person. And if you look at the graph to the right, it shows a standard deviation, and these little letters in there, the Greek letters for the different. Shows the different little letters of what each standard deviation is, all the way up to the fourth standard deviation on the larger side and the one that's going away from it. And it's pretty interesting how this works. But the mean and the median is all just about what it's supposed to be with this group of folks.
Very good. What an extra great thing we get to have an expert tell us about these particular scenarios. Thanks, Tinny.
How raises can actually make you less money, McCree?
So as in this graph, you can see that after he gets a raise, all right, see he makes $50,000, and after he gets a raise, he gets a $2,000 raise, so he makes $52,000. After he got that raise, he jumped up another tax bracket. So the way the tax bracket works is everyone in a certain amount of range, but they get the same amount each year, get taxed around the same amount. But then once you get up above a certain threshold, it changes and it starts taxing you a little bit more. And you can see that when he made $50,000, he was coming home with a 39, while when he got $52,000, just a $2,000 raise, he's coming home with 31, losing around 8,000.
Very good. Thank you, McCree.
How are the taxes in Arkansas distributed and the funding distributed evenly, Janet?
So looking at the Arkansas taxes, first you can look directly at the pie chart and tell that they're not evenly distributed based on the width and the section of the pie. If you look at the data, 29% of the taxes are for education, and roughly 25% is spent on Medicaid. What I found interesting in my research is that 34.6% is spent on unexplained expenses. So I think it's funny. That is a huge chunk of money that they are taking out of the taxpayers' dollars without really offering some type of explanation as to where it goes. The unexplained expenses is more than education and Medicaid. It is the largest section of the pie chart. So if the taxes were evenly distributed, then the pie chart would show an even number of sections with even widths. So,
Very good. Thank you, Bailey.
you're welcome. Where do a lot of our federal taxes get spent on? What do a lot of our federal taxes get spent on, McCree?
All right, so I made a pie chart for this, and you can see that actually a lot of our other taxes get spent on other, and it wasn't listed exactly what they were, but you can also see what other things are also spent on. And a lot of it's spending on education from kindergarten to 12th grade. I'm sure it's rebuilding schools to teacher salaries and paychecks and advances just to help the students learn, maybe anywhere from just furniture. But then you can see the next portion is also a Medicaid and children's health insurance programs. So what's the hospital name?
What was it?
But I was trying to think of the Children's Health Hospital, but I can't think of it.
I don't know either. Children's Hospital in Little Rock.
No, it's Arkansas Children's Hospital.
Yeah.
Very good. Thank you, McCree.
What happens with our tax dollars, Teddy?
You can see from these two charts here, one is for the federal tax dollars, one's for the Arkansas state tax dollars. The government uses our tax dollars, whether it be federal government or our state government, that our national tax dollars are mainly spent on healthcare, Social Security, and the defense. Our state tax dollars are spent mainly on healthcare, education, and pensions. I thought it was kind of interesting that the national government only spends about 2% on education, whereas Arkansas spends about 20% on education. And it just shows that locally we have a little bit better health with our schooling for our children and ourselves.
Very good. Thank you.
How can someone tell if something is evenly distributed, Janet?
Well, the first way to tell if something is evenly distributed is by sight. If something's evenly distributed, then all of the sections are going to be even. And that's not just on a pie chart. That's also on a bar graph or anything like that. The more that it increases and decreases, as long as it's even, everything else will be even too. So that's how you can tell. You can also do mathematical equations to find out, like if you have something that is increasing by 2 every time, then you know that it's being evenly distributed. But if you have something that is increasing by 2, then 7, then 6, then 4, and the numbers are kind of all over the place, then you know that it's not evenly distributed.
Excellent. Very clear explanation. Very good. Thank you.
What are the differences in wealth, McCree?
All right, so in this graph, you can see that the blue is the households in the wealth group. So the first 1% owns 35.4% of all the wealth in the United States, and that's a crazy amount of how much money they own in the United States compared to the rest. When you see that even the top 4% owns 27.7. So, and you start seeing when you start getting down, the amount of people and how much money they have starts getting increased, and it doesn't even come close to how much the first and even the 5th% owns.
Very good. McCree, go on.
Does getting a raise always result in more take-home pay?
Not necessarily. You can see from the graph here that someone that files marry or head of household, if he's making $50,000, he's got an 18.9 standard deduction. If he gets to the $52,000, his deduction jumps up to 28.9%. So, getting the grade, you've got a $2,000 raise, but it's actually going to cost you around $8,000. And you can see on the bar chart how much difference it is, from the amount that he's got deducted the taxes he has to pay and everything else. And so it's quite a bit of difference depending on how you pay. When we was looking at all these, there's a way of paying, filing head of household, married, joint, and then the single person is probably the least different.
Very good. Thank you,
Can a
Tinny.
pie chart be used for a good comparison, Lydia?
Well, yes, even though the bar chart showed things differently, the pie charts here, as long as you keep the colors the same so you can tell exactly what you're looking at, really show how many people in the United States, how little of the income, 4%, is shared by the people who are in danger because they don't have what they need, and in need, in other words, they don't have everything they need. I did it up to green being the first people who have enough to get a decent house over their heads and enough food. But as you can see, this little bitty tiny line here is 1% that have 35% of the wealth. It's really sad that they consider themselves aristocracy. And it shows by the way the rest of us are treated.
Wow, thank you. Very good and powerful.
And I think we just finished the presentation. Thank you, everybody.
Very good, you guys. Excellent work. Everybody give a thumbs up.